on the web interface. Luminosity, the latest value was 70. So it's a way to identify the device, even if I don't have his name. Well, the third way will not be demonstrated is by specifying Sparkle query language to identify the right device using semantics. Okay, so here we can get we have two ways to access the device. I can do the same for let's say for to trigger a command on an actuator. Let's try to do this. So I prepared the node to do that. Let's try to put the fan that is inside the house into the on state. First of all, let's check what state it is. So the fan is here. The latest value, sorry, or let's get it from here. Get state. So the state of the is on. So let's switch it off. So I will take this one. Okay. So what I want to do is and maybe, why not? And show the result of it. Okay, let's try. So I get all the message here. I didn't put an extractor for me, but what I want to see is that is the device now false. Oh, get state. Okay, this is the last value that been sent, false. So you can act on the sensors and the actuator easily. And now you can try to do some advanced scenario. I have prepared some for you. For example, let's do this one. In this scenario, I am triggering, I'm retrieving two values from my system. So the first one is a temperature sensor, and the second one is through a labeled sensor and for luminosity. So both. Okay, let's try. Okay, so I have the two values here extracted for me, 5 for the temperature and 70 for the luminosity sensor. You can do a lot of things. For example, let's try to mix to see, for example, if the temperature is under a certain threshold, we act on the fan. So to do this, I will sorry. Okay, I will start from something clear. Okay, let's go back to this one. So I have my temperature sensor. I extract the value that interests me, and pass to this value to a test. Okay, so if the temperature is under, let's say, 10 degrees, or over, let's say, 10 degrees, I will give it a name just for the interface. If this temperature is above 10 degrees, switch off the fan. Sorry. I need to put switch between the two in order to trigger the command. So the flow is something like this. We extract the value of the temperature sensor. We then look into the interesting value inside the response. Test this value against a threshold. Here I set 10. And if this value is true, if this condition is true, I will trigger the command of putting the fan off, in the state off. And I will show the result here. Again, I need to do this to launch my flow. Okay. I get an answer. Okay, the state is false here. So maybe we can put an extractor here to see the exact state of the fan after that. So I'm looking into the field state of this data. Plop, erase. Oh, sorry, I did a mistake. Payload. Okay, my extractor is not working well, but okay, what is interesting to see here is the value of false that is shown here, saying that the fan has been switched off, because the command is to switch off, because the condition is true, the temperature is 5 degrees, it's under under 10 and not above 10. Oh, okay. Well, I mixed things, but okay. So this is just to add some flow control to your application. We can do very interesting things if you, well, with the basics, you can develop your application. But if you are familiar with JavaScript, you can do something like this. For example, you can extract, I prepared 2 nodes here to extract 2 values, and I can merge them and compute the average. For example, I retrieve 2 temperatures from outside, inside the house, or outside 2 buildings, and I will get the value averaged here. So the value, just for demo, it was 15, and here it was 25. Let's launch this one. So the average is 20. What I did there is there are some utility nodes provided by Node-RED, not only 1M, 2M contrib. So for example, here I used a join node to mix to join the 2 data, and small JavaScript code to compute the average. Small loop, and I average over the number of values. And I show this to, I'm showing this into the output. With Node-RED, you can do something that is very, let's say, very easy, and online services. For example, we can retrieve the value of a sensor, and based upon a condition, we can go online by, for example, tweeting, send a tweet. For example, your device, your temperature device that you are running inside your home can tweet about the temperature at regular intervals, etc. Let's try to do this. Okay, so just to know that Twitter does not accept the same message twice. So we need to personalize this. Oh, maybe. Okay. Okay, the temperature is low today in Hyderabad. Well, this is just the demo. If I go to my Twitter feed, I see the 10 seconds ago a tweet was there saying that temperature is low today in Hyderabad. You can also plug any online service. You can read emails, send notification to your phone, use text messages, etc. So it is very convenient to work with online services. And it's easy through this OM2M node to integrate one M2M. So you will have in the same place access to your IoT devices and an easy way to access online services. So it's very easy to develop an advanced application using this tool. Okay, so this is it. These are the basics of Node-RED. You can start prototyping rapidly. As you saw, I didn't specify anything about 1M2M, unless something like data, latest value, which are part of the vocabulary, but not limited to 1M2M. So this is a general use of this API. Okay, so for Node-RED, if you have any question, feel free to ask. Okay, some other examples that I didn't show. Retrieving the value of a sensor and applying a condition. This is what we did. Combine a sensor and an actuator. For example, here I will get a value from a temperature sensor. For example, also humidity sensor also. Combine the two conditions, see if both conditions are valid, then either switch off or switch on the fan. Asynchronous communication is possible also. So you can deploy a notification handler. It's sort of a server. Whenever you receive a notification from 1M2M, you can do something with it. For example, turn on a lamp, turn off the lamp based on the data you received in your notification. Okay. This is another tool that is that was developed to go along with Node-RED. So it provides you a sort of let's say dashboard, a visualization tool. So let's see it in action. So here I set up this emulation. I put background image in there to illustrate flat, and I can put in there the same idea as Node-RED, the actuators and the sensor. So here I'm mirroring, the latest value of the luminosity sensor, the state of the fan, the value of the temperature, and the state of the lamp here. It's normal. Okay, so you can, by drag drop entities here, you can build your visualization of your system. So here we are looking into the data that has that are in OM2M. So if I combine it with Node-RED, for example, let's go for something. Okay, sorry. example, let's try to switch on this this lamp. Sorry, switch off this this fan. I will go to. Okay, what do I have? No. Okay. Let's say that if the temperature is under 10, okay, this is the case. Switch off the sensor. Okay, there is a little problem. Let's see what is the result.
The condition has not changed.
The
temperature greater than 10.
I'm not changing the temperature of the sensor. So the sensor is always, the latest value of the sensor is still 5. Do you want to change it to, let's change it. Or 20. Okay. This is not working. Okay, it's still 5. Okay. Okay, there is blocking situation here, but okay, let's try on a different actuator. Okay, since this tool was designed to run against the mockup that will be that student will be using this Friday. So here I'm tweaking the tool just for the demo purposes. Okay. Okay, it will take some time to rewrite this XML. So let's keep this example away. So this is just to show you that by using the tool, when you will download this this virtual machine, you can develop your application here by designing the flows and see what is happening here in the emulator and the monitor. So you don't have to have real devices installed or running to get the application done. So in this way, This is a tool. I must say that this is a tool that you will be using just for prototyping. So you have an idea in mind, you have the description of your IoT system, but you don't want to go into the specification, the details of the technical specification of 1M, 2M, etc. So you want just to have something rapidly. This is the appropriate tool to do it. But after that, you need to go, in order to develop a robust application, you need to do it in another programming language, or by also looking into the details of the 1M, 2M interface. So what we did earlier to specify the headers, the content you are sending, the content you are receiving, etc. So for hackathon, for an event like this is very good because you can start rapidly, but it's not meant for let's say production-ready systems. So you have two, let's say you have two interfaces that will help you to develop an application using 1M, 2M. The first one is this Node-RED and this emulator. The second one, still the web interface, where you can find all the 1M, 2M stuff here. All the attribute and what was the result of your request, etc., etc. Okay. Okay, so this was the user point of view for OM2M, how to develop an application rapidly. Now, let's see how we can do something advanced and how to extend OM2M in order to integrate. The question was asked earlier, how to integrate a legacy or proprietary system or protocol. As I said earlier, this can be done through the development of an interworking proxy. The motivation are multiple: proprietary device, communication technology, non-IP technology. So the 1M, 2M protocol is not supported. Or you can use it to integrate with, let's say, online services too. It's not just for devices. You can use, for example, an IPE to access an online service like Twitter feed or social media, etc. Back to the architecture of an OM2M software. So you have a plugin-based architecture. What you need to do is to develop this missing plugin for your scenario. A quick overview of the IPE. So the IPE is this module that the core OM2M will look into when it needs to communicate with your specific device or system or platform, etc. And the role of the IPE, just a quick reminder, is that it's a piece of software that you are going to write that do communication with your devices that speak with the specific technology, do the translation into 1M, 2M standard, and put the data into the resource tree of the gateway. This is the first task an IPE needs to do. The second task is when you receive some request using 1M, 2M protocol from the outside, the core plugin will give you the request to handle, and it's up to you to do the translation between 1M, 2M message into your specific device. For example, let's say, typical scenario, I have my gateway here, 1M, 2M gateway. I have a device into my, let's say, organization. This device is a legacy one. He is using UDP datagrams, for example, to communicate with what I had before, my server. Okay, this is the legacy system, a device that is communicating with the server provided by the solution provider, yes. And I want, for example, to expose this device and its data to other third party. For example, a new actor that has new application and want to use my device. So what we are going to do, we are using 1M2M. The objective here is, when using 1M2M, is not the interoperability problem inside my IoT network, because I have just the same devices and I have already a solution, but it's just for exposing data to other actors in a standard way, a way that both of us will understand and can use. So this interface will be compliant to 1M2M protocol. And this is a third party. And my system is here. So what I need to do, is to plug a new module here, my API, that will continue to speak to the device using the same technology as before, for example, UDP. And this API will do the translation here, write the appropriate data in the resource tree, and that in this way the application can access this data. Let's suppose, for example, this device expose two types of information, measure one, and for example, one action. Okay. First step for you is to decide how to expose this data or this action. So let's say that under the gateway, so under the CSE, I will create an application entity called, I will give it the name legacy device, in which I will put a descriptor, why not, with the right description inside. And a folder for data. Let's say, for example, data measure 1. Under this node, I will have the content instances of measure 1, the history. And for example, a third container for actions. Action container, for example. And where I have the content instance. So this is the first step I need to do, to decide how I am going to expose this device to the outside world. I can do whatever I want here. So I choose to expose three types of things. A descriptor, a container where all the data will be stored, and a container where the history of this action, for example, let's say true, false, will be stored. Okay? So my piece of software that I need to do here will be composed of two parts. The first part is the code that you will need to write to receive your UDP packet, to receive your data, but also when you need to trigger command into the device. This is something that exists before, so you already know how to do this. What you need to do now is every time when you receive a data in this format, you interpret the data and put it somewhere here in the resource tree. So it's up to you to say, okay, I received the data, I need to put it, I put a new content instance under the container data measurement, measure 1. Okay? So this way the application can browse what is there, what is under this gateway. So the user, the application here will see this representation. And for example, if the application needs to get the latest data, he can, for example, using HTTP, because let's assume this connection is done through HTTP. So he will do a GET, let's say the gateway address, the gateway port, gateway CSE, sorry, and then legacy device, data measure 1, latest value. By doing this simple call through HTTP, this application has now access to the latest value provided by this sensor through a proprietary or a legacy technology. So this is how we will use 1M2M to integrate legacy devices. Now, suppose that you have exposed it to an action, this action here. The user will do something like this, a post. And for example, the action is a parameter of this resource. For example, operation equal start. Let's say that we have a command called start that has been exposed by your device. So by doing this call, the request will be received by the gateway CSE. The gateway CSE analyzes the request, sees that you are targeting this application entity, will redirect the request to the IPE that is handling this application entity, and it's up to you to interpret this request and do the necessary here to trigger this action. Something that you already know how to do it. So this is the two tasks of an IPE that you need to implement in order to get your device integrated. Yes? Of course.
I have two doubts basically. One is from this context, the communication standards, for example, SNMP, PDMO, that is the guidance for managed objects, they have pretty much similar structures. For example, to use the southbound and the northbound devices, where the sensors will be the northbound and the southbound and the application will be the northbound.
Exactly.
So if we use the GDMO kind of thing, I think probably pretty much is well tested and it is interoperable at that level.
Here.
Okay.
Yes.
So why M2M or one M2M is supporting the GDMO kind of things, or it is only the purely different protocol?
In the north band or on the south band?
No. See, southbound anyway is different.
Okay.
How to interface with the
Okay.
device.
Okay.
And the way that we are going to build the data structures, I mean the tree here, the resource structure.
Yes.
If you use the standards like GDMO, there is the guidelines for managed objects.
Okay.
And SNMP,
okay.
where you can do the MIP walkthrough. So pretty much standard. So where the M2M's gateway will be much more interoperable with the more number of devices.
Ah, okay. I saw your point. So, if I understand, why 1M2M can integrate, why we are saying that 1M2M can integrate a lot of devices?
Yeah,
Or
if we have the GDMO interface, for example, if we interface with the GDMO.
I'm not aware of it, but I guess it's something like this. It's no.
Both.
Ah, here.
Yeah.
Okay.
SNMP has two.
For managed objects,
Yeah.
SNMP also gives you, but SNMP would not probably give you the way, the
GDMO gives.
descriptive way or generic way of handling
Right, that's-
mobile location and those kind of things. SNMP, for that you really need to have another tree.
No, that's agree. But if you use the SNMP, you may not be able to do an action. But if you use the GDMO, you can take the action.
Is the question about this organization or no?
Both, sir. See the way inside the gateway box.
Yes.
See, there are two factors. That is, one interfaces with the application.
Yes. Here.
The side, and other interfaces with the device.
Yes.
Now we are talking about interface, the northbound interface. That is from the above. Yeah.
Between the IPE, for example, and
Not,
this one.
From the gateway of the box. From the gateway
two.
to the app.
Okay, this one. Okay.
This is the interface. An app between the gateway is the same interface. It's probably MCA is the same message, the same primitive. It's exactly the same. An application could be a sensor, could be a mobile application.
Exactly.
It's exactly the same interface.
Right. But those devices which are kept as the GDM objects here in the gateway,
Yes.
the digital representation of each and every the sensor or whatever as a GDM object, then automatically a lot of tools are available to connect with them as well.
No.
The
Management,
management.
device management, one is doing it done by lightweight M2M, by TR69 or AMATA. Because it's very service provider. We are talking at home, you don't need to manage it at home. We are talking about service deployed on the operator on the nation side. So it's more about, let's say, the OADPM or switching the protocol that are standardized using one M2M. But if you want to manage, if you want to not using, let's say, operator device management, you can use this as SMTP, but you don't need at home, you don't need to manage it. Just lightweight M2M, TR69 and OADPM.
Yes.
I will let it make.
Okay. Thank you. Okay. So these are the two tasks that an IPI needs to implement. If you want to do it using OM2M, OM2M is written in Java. So there is a tutorial on the wiki. I can show you where to find all this information. So if you go to om2m.org, you will have this interface. So you have links to how to download the source, how to clone it, to build, how to configure it and start it if you have a specific scenario. But the default configuration can fit a lot of users. What to expect from the web interface that I have shown you. The REST API, a tutorial to redo this, what we did earlier, the creation of an application entity, the containers, the content instance, and even the subscription notification part. And finally, you will have the tutorial for developing a new IPE. If you go there, you will see a very detailed tutorial step by step how to create a new project using Eclipse, how to configure it, how to run, how to integrate it into the software OM2M, etc. And also an example, simple, that we developed. For example, let me show you. No. So you have even the code source explained and how to personalize this code. Okay. So next step, I'm going to show you an IPE, an example of an IPE that is already available in source code you can download from Eclipse. It's called IPE Simple. So basically, it's an interworking proxy that communicates with two virtual light bulbs. The communication between your IPE and the two light bulbs is non-1M2M. Well, they are located into the same program, so there is no protocol, but what we need to keep in mind is non-1M2M interface. And we are going to show how these two virtual light bulbs are being reached outside using 1M2M interface. So to run this example, let's run this light, under the office building. So if you go to your application, the software application of the MN, you can show all the plugins that are available by this way. And the plugin I am interested in is IPE Simple. Here it is. So it's available, it's resolved, but not started. So first thing, I will start it. So start, the number of the IPE is, in my deployment, 30. So start 30. Okay, so I got this application running. Okay, let's see what happened in the resource tree of our middle node for the office building. So if I go to the office building, okay, back to the IN and then to the office building, I will see that there are 3 new application entities created: lamp 0, lamp 1, lamp all. Because you are free to represent your system whatever you want here. We choose to represent the 2 lamp by 3 application entity. So the first one, the first 2 are for the 2 lamps, but we added a virtual application entity to represent the 2 lamps simultaneously. So the IPE created this representation. So we can see a descriptor and a data. For the descriptor of the first lamp, we got this attribute, for example, type lamp, location home, the name, and some operation exposed, for example, switch on, switch off, toggle, or get the state of the lamp. If I do get the state of the lamp, let's do this. Okay. So what is the state of lamp 0 is false. I can choose to switch it on, and the command is working correctly. Same thing for lamp 1, sorry. I can switch on, switch off, toggle, etc. And the virtual resources that has been created, set on, set off, the command has been translated to switch on the two lamps. Okay. So this is how you work with IPE. If you look into the code, an enter-working proxy in Java, because we wrote the software in Java, is an interface composed of 2 methods. The first one is do execute. It's what is called when you receive an 1M2M request and that was directed to you. So what do you do with the request? So it's up to you to say that, okay, if it is, for example, command start, I need to send the message start, I need to initiate the communication, etc. It's up to you to interpret this action. The second method that an IPE expose is an application point of contact. It's just string. You need to give to identify your IPE. Because the 1M2M core will use it to redirect you the request, the appropriate request to you. So based on the name you are giving, it will give you the requests that are addressed to you and not to another IPE. So what you need to code is how to handle 1M2M requests and how to translate them into your legacy system. The direct communication of your devices with your devices, it's up to you. And finally, how to populate the resource tree, how to organize it, etc. So these are the 3 tasks you need to do to write an IP. What happened, as I said there, for example, let's say that we have an application using the 1M2M standard over HTTP, and we get the request received by our HTTP server in the core. So this request will be given to, let's say, the core plugin of OM2M in a protocol independent format. We don't need to know that this request was received over HTTP. Okay? So the core, first thing it will do is to persist this request, because every request is persist. And then, because we saw the URI, the core will choose the right IPE and give the request to this IPE to be translated. So this is the flow of a request inside the OM2M. And the same thing if, let's say, if we receive data from your device, first it will go directly to your IPE, and the code you write in your IPE will give the request in an independent format to the core, and the core store it at the right place of the resource tree. Okay, so this and this presentation about Node-RED and the extension of OM2M, I added, let's say, a scenario, very important scenario about access right. This is something important in 1M2M. So let me, this is a continuation of the tutorial of this morning. So let me get back to the old scenario. Okay, so the scenario of this morning, we have just one CSE in which we created one device. So I will need to populate the tree because the tree is now empty. So this is what I have in my node, just the INCSE. I will create the application. So I will redo the, okay, so create, okay, the descriptor instance, the data, one data, okay. So we have this now, the application sensor, the descriptor, one content instance, and one content instance in the data form. 1M2M has designed standardized a way to control the access to these resources. Every resource can be controlled. The access to this resource can be controlled. Let's see. In 1M2M there is a resource called ACP, Access Control Policy. So in OM2M, in our implementation, a control policy is created automatically for a user. So at the beginning, we created an access policy admin for the user admin. And in this policy, we have set the following information. So we said that the user admin has full privileges, but the user guest with password guest will have 34. So if you remember, and can get the information of resources. He cannot create, update, delete, or be notified about resources. So this is the two profiles we have defined. So let's see what happens if I want to modify this rights to the user guest. Okay. So let's see, for example, okay. So here I have set up a request with using the originator guest, and I am looking to retrieve the state, the information about the CSE. So I'm targeting the root of the tree, and I can get the information about this this CSE. Let's now update information about the guest. So here I am updating with the message put the ICP admin resource, and now I'm saying that the user guest get nothing. Okay, so it was updated. The same request I did before to get the state of CSE will be unauthorized for this user. So, and you can do this. So you have a lot of, you have 6 flags for retrieve, retrieve, update, create, delete, and to be notified. And you can choose the right flag for every resource you want, if you want to. But there is a mechanism that propagates the access rights under the same subtree. So it's up to you to keep the same access right for the entire tree or for specific resource, etc. You can also create profiles, policies for different users, and you can change it. You can, for example, have a third-party server where the user authenticate and get policy and then access an OM2M or 1M2M server. So there are a lot of interesting feature in 1M2M. So this one is one of them. But you saw that with small features you can already write an application. So you don't need to know the entire specification of 1M2M, which is complete. There is a lot of things there. There are new features, for example, to manage time series. If your device is time oriented, so how to explore this history of your device, how to analyze it. 1M2M can be seen as an enabler for big data because for analysis. So you have a way to different way to expose data to the application. You can select an interval from this time series, etc., etc. Another important feature in 1M2M is group management. If you remember the example of the 2 lamps, the guy who did the IPE decided to represent these 2 lamps by 3 application entities. One, the two for the 2 lamps, and the third virtual for the group. 1M2M has already a native way of doing this. So we could use another feature of 1M2M, which is called group management. You can specify a group and what is inside the group. And once you did a call to this group, this call will be replicated to all the members of the group. So for example, let's say that we have 10 lamps inside the room. I will create one group in which I put all the 10 lamps, and I will send just one request to this group and set the lamps on or set the lamps off. So a lot of features, but you don't need them to start writing application. It's up to you, it's up to your scenario, it's up to your energy to use the right feature of 1M2M. Okay. So this concludes my presentation. So if you have any question.
So I think we have finished 5 minutes early from the planned break. So there will be a coffee break for just a second.
OM2M at LAS. So we are a team called SARA for service, advanced service on network. We have several people on the PhD student that work on OM2M, and some other we contribute in terms of new research in domain of IoT. So just to map with an architecture of IoT, we saw the devices, the gateway, several levels of gateway, some servers, and application. So in fact, in the team, we cover different parts of this type of architecture. We work on the network part with low power wide area network like LoRa network. We also work on communication through a gateway on server with a new way to exchange information. We also work how to configure and reconfigure this infrastructure to maintain good quality of services. And to do that, we also use device management. And finally, we try to make high-level services for user made with a composition and use of services when we discover new services. We also work on QoS, quality of services, for all the middleware part, and we use this on a real use case in a building called a Dream Building, and I will give you a few information. So it's a quick survey of what we will do in the team, and for each subject it's only 1 or 2 slides just to give an input in this subject. So for the LoRa network, the goal is to manage deployment of gateways. In fact, it's LoRa is a network based on an open frequency. It means that everybody can create his own network, and it's a network that you can use to communicate for several kilometers around the gateway. So it's quite a long-range network. And we think that people will deploy this kind of network. Operator will deploy, city will deploy this network, and that's what we can see around the world. And when you have several gateways, several or many devices, there is some conflict because it's a network where you push data, you try to communicate, and you don't know if it's happened correctly or not. So when the density of devices become too heavy, because it's LoRa protocols, in fact, you can transmit on the air. So we made some estimation of the throughput depending on the density of devices, and to have also localization. It means that always we need to have at least 3 gateways to communicate with. So we prove that if you increase number of gateway, number of devices and density of devices, we see that the throughput becomes lower because you have a lot of conflict on the frequency, which is natural. And we estimate and simulate these behaviors on devices on LoRa network. We also work on information-centric networking. In this kind of network, the goal is to remove all systems based on IP. So you don't have any address, no. And we use a new way of communication. In fact, when we need an information, an application needs an information, she sends an interest to say, well, I will want to know luminosity in this room, in this place. And the application sends this message on the network. And the network should find how to respond to this interest and give back an information about the luminosity. So we need to discover where we have this information, or perhaps it will be stored on the network, and perhaps we need to make an interrogation to the producer of this value, the sensor of luminosity. But we don't put an address on the request. We just say, I would like to have this information. In fact, it's like what you do in a browser. When you want to have an information, you just put a word to say, well, I would like information about this, and the browser get the information. So the same thing for this kind of network. So we can remove all IP and do a network like this. So some people have done some experiment on this. And to do and produce this kind of network, you need several new functionalities. First, you need to make a naming of all information, to find a way to get and to specify each information in the network. So you can have some hierarchical way of doing this, or some other way. You need also some caching inside the network. So when you make an interest, perhaps the information is just near you, near the first router in the network, or be far away, and you can get this information directly from the network without make an interrogation on a server. The last part of the things to do to make this kind of network is to make a routing. When you make an interest, you need to find in the network where you go in the router, where to find the producer if you don't get the information. So you have some routing table based on information, not on address in this kind of network. So we have worked on different parts for this kind of network. First, we work on a mechanism of cache, and we specify a new mechanism based on an observation of internet traffic for the sensors and activator. So we study, for example, if it's a periodic information, and we make an evaluation of freshness of data on the network. And if the information is too old on the network, we can produce a request to the producer to anticipate a need for a specific application. So we involve the response time for user. We also work on mobility. So when a producer moves, if it's a smartphone, for example, that gives this information, it can move and be connected to another router. So when we want to have an interest on this information, we can't go to the producer, this producer. We need to reroute the interest to this kind of sensor, in the new location of the sensor. So we produce some algorithm to make link discovery of failure and make a recovery of links. We also work on global infrastructure to make a reconfiguration of the communication layer. And the goal is to make this at different level, at the network level, middleware or application level. And Samir work especially on this kind of subject. And to do that, we use the concept of virtualization and softwareization of service. So you can deploy service around the network and create new services for the network, for example. And to do that, you can also use SDN to have an evaluation of traffic, of what's happening on the network, to make a good decision on make a reconfiguration of the network. So there is a problem of monitoring, how to evaluate the state of the system with a specific architecture like cloud, fog, or edge environment, and also to have a modular application where you can move services and deploy services dynamically and also autonomously without human intervention. So you need to do that with data analysis, for example, with complex event processing or stochastic model, and after you can do the reconfiguration. We also work at the level of device management to help and to manage the deployment of services. So to do that, we have made a connection with the lightweight M2M protocols. It's a dedicated protocol that can manage devices. So with this protocol, you can make an update of firmware, can deploy or reconfigure software, modify some parameters. We have done a connection with 1M2M. So in lightweight M2M, you have some client on the devices, and this client can communicate with the server. On server, will join and make and send information to the client to say, well, you need to update this firmware, you need to change this parameter. So we make a connection with lightweight M2M. In fact, it's only a new interworking proxy to made. And with this kind of feature, an application can communicate with the lightweight M2M and then send information to one M2M, and you can interact with an application at this level. But also, you can use one M2M directly. And you can also send a request in one M2M, and you can transfer to lightweight M2M to, for example, deploy a new service on a specific devices. So in fact, it's very easy, because in lightweight M2M, you have also a REST architecture, and we map using a document, a standardized document produced by one M2M consortium to make the mapping between one M2M representation and lightweight M2M representation. So it's not a difficult job. And it's an example of IPA that Samir have presented before. So we have a plugin, a specific plugin that implements this. So we can deploy a lightweight M2M server and make connection with an existing client. And all of these are open source. On Eclipse IoT, you have also a server to do lightweight M2M, or also client. It's called Leshan on Wakayama. So now we have many things, and we can go on the application level with the service management. So on this level, the goal is to manage a high number of services and dynamicity of the system. So when we use services from IoT, but also from information platform like governmental platform, city platform, where they can push some data and give some services, you need, when you want to deploy a complex application, to understand the system, to see what we can do in a specific place. So for example, we have some scenario with a bus in a city, and the bus with people inside the bus will discover different kind of... Oh, it's okay. A user goes through the city, and depending on where he is with the bus, he can have access to new services. So for example, it could be a shop where you can have some discount, and you have new services on your smartphone that start and say, well, because you are in this bus, we know that you arrive in 2 minutes near this shop, we send you a discount and say, well, you can come and see us. So this is a kind of services that mixed IoT system and also information system on the shop where we have some discount values. So to do that, we need to discover, compose, and use services in the same way with an autonomous system where there is no human activity to make this. So to do that, we use several theories. First one is based on semantic. So we have deployed at last a new ontology called IoTO. IoTO help you to describe sensors using SSN, which is a well-known ontology. We have also an ontology for activator, for life cycle of services, to know that we can deploy, use, and stop services. And we also We also have some modules to manage energy of devices. And with this ontology, we can also express some interest of users. So user can say, well, I am interested of this shop. I have some problem with the pollution of air, so I should be very careful if this the level of pollution is very high in this place. I mustn't go there. And also, we can express some information about devices. What can we do with the devices? For example, if it's a display, if we can share this display or not. If it's a smartphone, we can't. But if we are in a bus with a screen, we can share the screen and put some information that will be interesting for several people. Then we use a representation based on a graph. So we use a graph grammar on rewriting rules. In the rules, we express that we want to find this pattern inside the graph, then we will remove a part of the graph and add a new part of the graph. So like this, we can change dynamically the graph, express the rules offline, so we can verify a set of properties. For example, if we want some robustness, we can say, well, devices need to have always at most several services connected. So we charge a pattern, find a link, destroy, and add a new link. And to manage all these models, we use autonomous system. This is a theory deployed by IBM in 2001. And in this system, we make a loop, a control loop. So we want to manage a system. The system gives information. So if it's, for example, this room, we can collect some information about the temperature. We can collect information that there are some people inside this room on the luminosity. All this information are sent to a monitor. This monitor will do some management of those events. For example, it will make some correlation, filtering. And depend of the event, it will create a symptom. So for example, if the temperature of the room is 10 degrees and there is some people inside the room, we create a symptom to say, well, the temperature is low. Then we analyze this information and using models, we make a request for change to say, well, we need to up the temperature of this room now. So we send this information to a planner. He will observe what he can do in this area. For example, he can close the window because we are in winter, it's very cold outside. But also we can switch on the heating system. So we make a plan, send this plan to the executor, and the executor will use the real effector in the real world. So it's a way to manage a system and to give him the way to think, reasoning, and make an action on the real world. So we also deploy a tool called FrameSafe to do that. And we use it, for example, on a scenario in a smart city, where we describe a user that moves in the city. We transform this ontology and make a reasoning on ontology, transform the ontology and extract specific information. And with a graph grammar, we can do and prepare some real execution plan for the real world.
Standardization of things, right? So what's there in this specific scenario? How does standardization fit in?
Okay. So in fact, in the lab, when we have produced OM2M and work on standardization, we do that to have a tool to express and to show different type of researches. So, for example, on OM2M, we have had a plugin that give to a system autonomous capability. So you can get information from the sensor and do some reaction on effector, and it's included in OM2M. This is not standardization, but it gives a new capability to a system based on OM2M. So this is a way.
Can you say it's a case study in terms of the implementation of a solution using OM2M?
Sorry?
It's one of a.
Yes, it's one of our
use case.
yes, it's over the standardization. So we have an activity of research on OM2M. It's only a presentation of our research, and we try to put inside OM2M. But we have several types of activities outside on standardization. It's only a part of the team.
Can I one more? In this context, the way we specify the physical system to the computer is a standardization process. Needs a standardization. There are some languages like Modelica is one of the languages where you can specify the system behavior, and then you can simulate that as well actually in the Modelica. So can we use such languages so that the language itself, let's say to give the Modelica's model.
Yeah.
It's the way you specify the system basically. So then I think the logical things, for example, if the temperature sensor is greater than certain degrees or something, they all come under the standard models where you can express them in the language what is there in the Modelica is one of the languages.
Yeah.
Can
So-
you use that?
Yeah, we don't use that, but in fact, in autonomous computing, you have a knowledge base where you use model, and you can use several type of models. So it's you can see it as a framework. In fact, it's a framework that takes some information from a different type of system and do some reasoning and manipulation of this.
So the user is free to use any kind of models there, whatever that a user wants to implement that model.
Yes, yeah, you can use several models. And we develop a tool that in which you can make some connector with different kind of models. So we use, for example, tune system, we use ontology, we use graph. Depending on what we want to do, we use different representation, and we use the same tool, for example, to manage energy on a cloud. So we can switch on, change the frequency of host to save energy. And this is the same system, but it's not IoT. Yeah.
Some kind of inbuilt intelligence as well? Is it like a module with some kind of intelligence as well?
The intelligence here is made with reasoning of ontology, but we can have some data analytic, machine learning inside the system. Yes, yes.
But so I think
And
these
Samir work on this.
Some kind of tools. So as a package, are these also kind of given as a package?
No, it's not share. This one is not share. But we can trade cooperation. And yes, with partners, we give or make some exchange. Yes. But we don't give it as an open source. It's more cooperation between partners. But we are very open and be happy to come back here and work with you. So we also work on quality of services inside OM2M. So just a few results. So this is a GET. A GET or post? A post. This is a post made on OM2M platform, and we saw that, for example, at the beginning, when we start to make some post to change the value and create a new content instance, we have some long. It takes a long time sometimes for some request, and after it's always the same. In fact, it's very low. So we study a little this to see that there is a problem, some caches inside OM2M on the database, in fact. And at the beginning of when we're starting to make some post, we need to load some resources inside the cache of the database, and it take a little time. We also do some request and see the global response time of the system, and we see that depending of the incoming rate of a request, we can have a very long response times. So it's a way to see how the platform can be scalable. So we need to work on this, and we propose a model based on a queuing system to modelize inside OM2M what's happened. So for example, when you use HTTP server, you have the request from the network that is managed by the HTTP server to decode and analyze the request. Then you have a pool of threads that manage the request on the service. And also you have an access to the database for the resources before to leave the system and respond to the system. So we modelize this system with a queuing system, with the PCMP queuing system. And we manage also energy on a gateway. So we want to have a fixed response time in the system. So we start and stop core on the same gateway. It's a gateway with 4 cores of processing. So depending on the measured and predict incoming rate, we can start or stop a core to stay at the same level of response time. So this is some work we do also on QoS for OM2M. Finally, we work also on a real use case in a building called A Dream. So A Dream is a building that we have been created in 2012. This is a building which several types of renewable energy sources. So we have a solar panel all over the building on the front, but also on the floor. We also have some energy take from the floor with a geothermic system, and also some pump. And this building is quite interesting because it's also a technical platform. So we have some demonstration, we have some big room to make a manipulation, but also we have a reproduction of a flat and also some office. And everything is mixed in this building. And also we have a lot of sensors, more than 7,000 sensors inside this building and activators. We can monitor heating, ventilation, lighting, electricity consumption with a lot of smart meter. We have also some environmental data. And all the data collected are stored in a database. So every day you have more than 5,100 values inside this database. So those data are used to manage the building, but we also can use to do some data analysis on a building, on a smart building.
Is the database public?
Yes, I will show you the link, and you can have access to all the data, raw data, and also semantic data. So we had some sense, because if you take the raw data, it's very difficult to know that number 1222 is a sensor of temperature. So we have done also this work. So in the flat, we have also deployed some autonomic management of sensors on activators, and we also make some cooperation with the robots. So in robot, there is an open operating system called ROS, and ROS is based also on publish subscribe. So we have a specific interworking proxy that discusses with the ROS system, and with this, the robot can go inside the flat, discover sensor and activators, and after he make a communication with 1M2M, and he start to manage all the flat. The data of the building are open, so we have created an open data at these addresses, syndream.last.fr on this port. So if you go on this website, you can ask to create an account. With this account, you have an access to a subset of data, and if you ask more, and if we have some partner area, we will give you an access of full data of the building. We also have created in the past some open services, but we have stopped this. We have deployed OM2M in the flat, and people can access to the flat remotely and can switch on, do some manipulation. But we have a problem of concurrent access. So sometimes you are in the building and you see the switch on and switch off of light or fan, and it was quite complicated to manage. So we stopped these services, and people must go inside the building to make manipulation. So on OM2M, just a few information on the roadmap. So you have an access to the MOOC, and Sachin has sent an email to everybody. We will publish very soon some new functionalities on Eclipse. So you have today a demonstration of Node-RED, but in fact you see only a subset of Node-RED. We have several other possibilities, and we've done that with another university in Taiwan. They also work on Node-RED, and we both put our own implementation, and we publish on Eclipse. We have also worked on semantics with another lab in Toulouse called IRIT. So we have a version that implements a subset of semantics in 1M2M, and the semantic descriptor and some discovery functionality. We also have a lightweight M2M connection, and we publish very soon on Eclipse because company ask for this. We also make some demonstration, for example, secure bootstrapping. This is also asked for company. When you want to add new devices, you need to be sure that the devices can connect and be accessible on your network. So we have a system of bootstrapping using lightweight M2M. We also have some cloud management, how to deploy and make an architecture scalable using, for example, the model based on an queuing system. And we have also several APU, but some of them we can't publish them because they use some licenses not compatible with Eclipse. So we give some to the partners, but we can't put on Eclipse. So we have also some first results on performance, on dynamic management. And for the future, quite an important subset of the teams will work on fog computing. So Samir has some activities on fog computing. I also have some activity on fog computing, because I think this is a good way to manage IoT system. To have a centralized system on the cloud is not a good one. We need to have also some management, some service, some application near the user on a gateway. And we should manage this and make a dynamic distribution of information and services. So this is quite a quick survey of activities of the team.
Maybe already been spoken about, but what about the authorization of all the activities which can be done? Let's say when you can switch on and off one, but how do you take your authorization? Whether somebody is even authorized to do that. Authorization.
Security aspect. So in 1M2M you have several system and mechanism to manage security. So we see that we can secure the channel, we can have authentication with a login password, and you have also some token, and there's some other way in the standard. You have also the ACP, so to have a control policy of each resources. So you have a lot of mechanism. This is perhaps for small deployment, but you also in release 2 and also on release 3 you will have also a server to manage right on a complex architecture. So this is integrated in the standard. In OM2M, we don't really work on security. We make minimal system.
Research activities at OM2M. I would like to invite Sachin Chaudhary for some concluding remarks and vote of thanks. And before that, I would also like to point out this is my email ID. So Thierry pointed to some MOOC and other resources. In case if you have not received it, you can just send me a test mail and I can send it to you, because sometimes when we send email, it might end up in your spam folder or some other. So over to you, Sachin.
Okay, so I would like to give vote of thanks. So first of all, I would like to thank all of you to come here for this workshop, and I am sure that you must have enjoyed this session and learned something interesting and important regarding IoT and M2M platform. I would like to thank our speakers, distinguished speakers, Thierry and Samir. That was a really interesting presentation. And in future, I really hope that we see some, advanced version of this, like some hands-on session, some hackathon. It will be really great to have you again here. Okay. And I also thank all the distinguished dignitaries who have attended this session. So Lauren from ETSI, Klaus Pendel and Rahul Gupta from EU Delegation India, Vijay Madan from TSDSI, and I think, yeah. So next I would like to thank all the IIIT staff and students, volunteers who have really helped to organize this event. And special thanks to Ramana Garu and his team from General Administration. And also special thanks to our Karthik Raj, who has put the most or maximum energy and efforts from IIIT for this event. Okay. Last but not the least, so I would like to thank my friend Sachin from Aalto University and his colleague Alok for organizing this event at IIIT, and we are really hopeful that we would organize many more interesting events like this together in future. And I would like to, so
before you say, I just like to say two things.
Okay.
So I would like to just mention that I think among all the 4 partners that we have worked, that you are one of the most proactive. So I would really like to thank you for all the effort that has been put.
Thank you.
Because even prior to the event, you got a press release done, and it was here in local newspaper. So that kind of effort is really appreciated. And second thing I would like to share, which I was also talking to Sachin, that I have already sent you a feedback form. So we would like to improve, and we would like to really know what could we have done better. So maybe, if you have any good ideas, so there is it's like a 1 minute form that you will take, but if you can fill it up and we can work on those ideas. Yeah, thank you.
So from Triple ID side, I would like to really thank all the distinguished or dignitaries, and can we just have the mementos, please? Can you just announce? I will request Sachin to announce the names.
Yeah, so maybe to start with Professor Thierry, Triple IT would like to felicitate you. Then Samir. Mr. Madan. Clause. Laurent. Then, if you allow me, I like to give you one.
Okay, but let me first.
So I don't know if I should be announcing my name.
Yeah, this
Thank you
is
very
Sachin. Yeah, come here. Okay. So he wants below the. Okay. Sachin to Sachin. Thank you.
But if you just give me a second.
Thank you. Okay.
Over. If any of you want to say any words, I would be more than happy to. Anybody to any feedback, comments, or we call it a day then. Thank you very much.